In this particular video, we're just going to go through some example images from cell cultures and try to figure out the confluency of those cultures. So this will just give you some practice making those observations. When we are looking at confluency of our culture, we are basically looking at what percentage of the surface area of the vessel wherever you're growing your cells is covered in cells. And for this, we are focusing on cells that are actually adhered to the cell culture dish or the vessel that you're using to culture them in. So the cells on the plate are going to be flat. They will be attached to the surface at the bottom. There'll always be some floaters, and you may see them as these little unfocused blobs every now and then. But majority of the cells should be attached to the culture when we are looking at them. So these are actual cells that are covering the cell surface area, the surface area of the plate or the vessel that you're using to culture them in. Now, you will look at this and you will kind of imagine what percentage of the surface is covered in cells. So if the entire slide is, or the image itself is 100% surface area, what percentage is blue, right? And so in this case, you can notice that maybe around, let me see if I can get a pen. I would say that about half the surface area is covered in cell and the rest of it is still white. So I would write the confluency of this culture as 50%. So that is how you would do that. Okay, so here we'll show you another example. Again, you're going to be looking at the surface area of that image and see what percentage is covered in cells. So I'll give you a minute to come up with your answer. So looking at that image, majority of the surface is covered in cell, but there are still areas that are white. And I would have thought that something between 75 to 85% would be considered appropriate for this amount of coverage. So again, this is a guesstimate, obviously. It is not a quantitative measure. This is just a qualitative measure. But done consistently by the same person in an experiment, it can give you an idea of how the experiment is working and how the viability of cells is changing over time or in the presence or absence of particular conditions. Here's another example. Typically, when we are doing this confluency, while you're looking at this image, you want to make this observation at a lower magnification. So scanning objective lens or maximum the low power objective lens. Some of the images in here are at 100x final magnification and other are at 40x to show you that difference. The reason is that at low power you're still seeing significant portion of that slide, and so you will be making a more accurate observation compared to if you were just looking at a portion. If you were doing this as a 400x objective lens using the 40x objective lens, so 400x, you'd be just focusing on a little tiny portion, and that won't be a very good observation, because if I happen to look in this area, it would look like a lot of cells, but if I happen to focus over here, it will be like there are almost a lot, significantly less number of cells. So that's not going to be as accurate as a scanning objective lens or a low power objective lens. So it's very important to make the confluency observation looking at cells kind of from a bird's view, right? Bird's eye view, rather than a more exact view all the way up close. So in this one, this is a lower magnification. This is a scanning objective lens observation. Looking at this, you see that again, significant portion of the cell of the surface area of the vessel is covered with cells, and you're going to be looking for those blues again, and I would say that maybe between 85 to 90+% is covered in in cells. So that would be the confluency of this particular culture. If you go back over here, this, just to remind you, this is a higher magnification. You can see the cells a little bit better here, and that tells you that too. Different cells are different sizes as well. So some cells look a lot more clear at 40x than others. These are the same cultures at 100x. This one, a different set of culture, obviously, because this is a lot lower confluence. And you can see the difference in cell number. Again, already you're looking at a smaller area. But looking at this one, again, you want to think about the general confluency of the culture. You're looking at overall cells in this area, and you're looking at, what percentage of the surface area is covered with cells. And this one is obviously a lower confluency. This is a lower confluence. So this would be maybe from, something between 25 and 35%. And I'm not giving an exact number, obviously, because it's a qualitative measure. When I'm looking at it, I may have just put it down as 33%. But anything between 25 and 35 can be considered appropriate for this particular culture. So I just thought that was important to give you that range, since you guys are doing it at home and thinking about it at home, so that you, if anywhere between that range, you would be, that you would have been counted correct. Here's one that is a little bit harder to figure out because it has these projections, right? So you have, this is a neuronal culture, so you have processes from those neurons. You have the cell bodies, and then you have the processes, right? So it's a little bit different to figure out. In this case, you want to focus just on the cell bodies and not the processes when figuring the confluence. So you're kind of not thinking about these processes that are covering the cell surface area, or the area of the vessel. Rather, focus on the cell bodies only when figuring out the confluence. So if you look at just those, it will be a different number than if you can include the processes in your measurement as well. And again, this is a relatively, low confluence culture, maybe even a little bit lower than the other one. So I would say anything between 15 to 25% would be considered appropriate for this culture. And finally, I believe this is the last slide. Here is one from a happy culture of HEPA-RG cells. And you can see this is a very confluent culture. This is definitely out of log phase of growth. So these cells have been growing happily, replicating, dividing. And you see very few areas that are empty, right? Almost negligible areas. You see a little bit here, and this little blob here. But overall, the entire surface is essentially covered. So this would be a 95+% confluence. Probably even, I would even go up to 97, 98%. So anything 95 or above would be considered appropriate for this one. Okay, so I hope this little, tutorial was helpful in figuring out how you look at confluence measurements and to decide the confluency of your cell culture when making some qualitative observations about your cells at the beginning and end of experimentation. We use this to make it to kind of equalize our samples, since many times when we are starting our experiments, not every single plate of your culture is going to be exactly the same. So by looking at their starting and ending confluency, we are able to make a ratio between the start and the end. You're able to equalize them somehow, give them some sort of a benchmark to compare to. And we will be doing some of that in cell viability in a couple of weeks. So hope this was helpful. I will be posting a few more for making similar observations with your microscope as well.